Good morning, dear students. Welcome back to physics class. Today, I would like to discuss on the topics which are A. Potential energy of an object at a height, and B is related numerical. In last class, you had studied the definition of potential energy. From this definition, it is clear that the potential energy of an object changes with change in its height. That is, the object's potential energy increases when it is raised through a height. This is because work is done on it against gravity while it is being raised. The energy present in such an object is called the gravitational potential energy. It is one form of potential energy. The gravitational potential energy of an object at a point above the ground is defined as the work done in raising it from the ground to that point against the gravitational force. We can derive an expression for the gravitational potential energy of an object at a certain height. Let us discuss on how can express the gravitational potential energy of an object at a certain height. Consider an object of mass m which has lifted from the position A to the position B through a height h from the ground, as shown in given figure. You know that force is required to lift the object. The minimum force required to raise the object is equal to the weight of the object, which is equal to mass into acceleration due to gravity, is equal to mg. When the object undergoes change in its position vertically, it possesses potential energy, which is equal to the work done against the gravity. Let the work done on the object against the gravity be W. So, the work done W is equal to force into displacement. Since force is equal to mass into acceleration, here acceleration is due to the gravity, so it is equal to g. Then work done W is equal to m into g into h. It is equal to mgh. Since work done on the object is equal to mgh, then the potential energy is also equal to mgh. So, PE is equal to mgh. Suppose an object of mass m is raised to a certain vertical height h through two different paths A and B. Then what should be its potential energy in two different cases? As shown in given figures, the object has traced two different paths. Let the height AB is equal to h. In both the situations, the work done on the object is same. It is equal to mgh. From this, it can be concluded that the work done by the gravity depends on the difference in vertical heights of the initial and final position of the object, and it does not depend on the path along which the object is moved against the gravity. What is the unit of potential energy? Its unit is same as work done. Then the SI unit of potential energy is joule and its CGS unit is erg. Do you know what should be the conversion of energy from SI unit to CGS unit? 1 joule is equal to 10 to the power of 7 ergs. See this conversion. 1 joule is equal to 1 Newton meter. which is equal to 10 the power of 5 Dans into 10 the power of 2 centimeter, since 1 Newton is equal to 10 the power of 5 Dans. Then it is equal to 10 the power of 7 Dans centimeter is equal to 10 the power of 7 ergs, as 1 erg is equal to 1 Dans centimeter. You have to know there are three types of potential energy, which are gravitational potential energy, chemical potential energy, and elastic potential energy. Gravitational potential energy derives from an object's height and weight. Chemical potential energy derives from the atoms of an object and the chemical reactions that taking place within the object is responsible for this energy. And elastic potential energy of an object is due to the compression or stretching of an object. Answer the question. A body of mass m is raised to a vertical height h through two different paths A and B. What will be its potential energy of the body in two cases? Give reason for your answer. The potential energy in both cases is equal. It is equal to mgh. It is independent on the path followed by the object for attaining the height. Let us discuss on the numerical part. Question number 1 is, an object of mass 12 kg is at a certain height above the ground. If the potential energy of the object is 480 joules, find the height at which the object is with respect to the ground, given that g is equal to 10 meter per second square. What is its solution? This question gives two more values. First one, mass of the object m is equal to 12 kg and its potential energy is equal to 480 joules. We know that potential energy Pe is equal to mgh. Here we have to find the height h. So height h is equal to Pe divided by mg. By substituting the values of Pe, m and g, we get height is equal to 4 meter. The object is at the height of 4 meter. And the second question is, 75 kg missile is dropped downwards from an aeroplane and has a speed of 60 meter per second at an altitude of 850 meter above the ground. Determine the potential energy possessed by the missile at 850 meter, given g is equal to 10 meter per second square. The solution is, given that mass of the missile m is equal to 75 kilogram, acceleration due to gravity g is equal to 10 meter per second square, and height h is equal to 850 meter. We know that potential energy Pe is equal to mgh is equal to 75 kilogram into 10 meter per second square into 850 meter is equal to 6,37,500 joules. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.